Section 1.6, the design of experiments. These are the objectives we'll look at in this section. Objective 1, we want to describe the characteristics of an experiment. So let's look at some definitions. An experiment is a controlled study conducted to determine the effect of varying one or more explanatory variables, or factors, has on a response variable. Any combination of the values of the factors is called a treatment. The experimental unit, or the subject, is a person, object, or some other well-defined item upon which a treatment is applied. A control group serves as a baseline treatment that can be used to compare to other treatments. A placebo is an innocuous medication, such as a sugar tablet, that looks, tastes, and smells like the experimental medication. Blinding refers to non-disclosure of the treatment an experimental unit is receiving. A single-blind experiment is one in which the experimental unit, or subject, doesn't know which treatment he or she is receiving. A double-blind experiment is one in which neither the person in the experimental unit nor the researcher who's in contact with them knows which treatment the unit is receiving. So let's look at an example. The English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, a faculty member randomly splits a section of her course. Half the students receive the traditional and the other half is given on online. At the end, both groups will be given a test to determine which performed better. So first, who are the experimental units? This is the subject, which would be the students in the class. Next, what is the population for which this study applies? Remember, the population is the larger group, so that would be all students who enroll in the class. Now let's look at what are the treatments. They are looking at traditional versus online instruction. Now, what is the response variable? We're looking to see how the treatments affect the response variable, which is the exam score. How do students perform on an exam given the type of class they were enrolled in? Why can't this experiment be conducted with blinding? Namely, because both the students and the instructor would know which treatment they're receiving. Objective 2, we want to explain the steps in designing an experiment. To design an experiment means to describe the overall plan for conducting the experiment. So here are the steps. The first step is to identify the problem to be solved. And here's some things that need to be true. It should be explicit and clear. Should provide the experimenter direction. It needs to also identify the response variable and the population to be studied. And then often the statement is referred to as the claim. Step 2, we want to determine the factors that affect the response variable. Once those factors are identified, it must be determined which factors are to be fixed at some predetermined level. This is the control. Which factors will be manipulated and which factors will be uncontrolled. Step 3, we want to determine the number of experimental units. As a general rule, choose as many experimental units as time and money allow. There are techniques that exist for determining sample size, provided certain information is available. Step 4, we want to determine the level of the predictor variables. So first, there's the control, and there are two ways to control the factors. A, we fix their level at one predetermined value throughout the experiment. These are variables whose effect on the response variable is not of interest. And B, we set them at predetermined levels. These are the factors whose effect on the response variable interests us. The combinations of the levels of these factors represent the treatments in the experiment. Secondly, it's important to randomize. Randomize the experimental units or subjects to various treatment groups so that the effects of variables whose level cannot be controlled is minimized. The idea is that randomization averages out the effect of uncontrolled predictor variables. Step 5 is to actually now conduct the experiment. Replication occurs when each treatment is applied to more than one experimental unit. This helps to assure that the effect of a treatment is not due to some characteristic of a single experimental unit. It is recommended that each treatment group have the same number of experimental units. Then we collect and process the data by measuring the value of the response variable for each replication. Any difference in the value of the response variable is a result of differences in the level of the treatment. And step 6 is to now test the claim. This is the subject of inferential statistics. Inferential statistics is a process in which generalizations about a population are made on the basis of results obtained from a sample. Provide a statement regarding the level of confidence in the generalization. Methods to do this will be presented later. Objective 3, we want to explain the completely randomized design. A completely randomized design is one in which each experimental unit is randomly assigned to a treatment. So let's look at an example. Here, the octane of fuel is a measure of its resistance to detonation, with a higher number indicating higher resistance. An engineer wants to know whether the level of octane in gasoline affects the gas mileage of an automobile. Assist the engineer in designing an experiment. So the first step, remember, was to identify the problem to be solved. And this is often the claim. So the response variable is miles per gallon. Step 2 are the factors that affect miles per gallon. This would be engine size, outside temperature, driving style, driving conditions, and characteristics of the car. Step 3, we will use 12 cars, all of the same model and year. Step 4, we list the variables and their levels. So the octane level will be manipulated at 3 levels, with treatments A, and treatment B, and treatment C. We're going to fix the engine size. The temperature will be uncontrolled, but will be the same for all 12 cars. The driving style conditions, all 12 cars will be driven under the same conditions on a closed track, fixed. Other characteristics of the car, all 12 cars will be the same model year. However, there's probably variation from car to car. To account for this, we randomly assign the cars to the octane level. Now step 5 is to actually perform the experiment. So we randomly assign 4 cars to the first level, 4 to the second, and 4 to the third. Give each car 3 gallons of gas, drive them until they run out of gas, and compute the miles per gallon. Step 6 now, we determine whether any differences exist in the miles per gallon. So this is a completely randomized design, and this gives us a good picture of what we've done in our experiment. Objective 4, we want to explain the matched pairs design. A matched pairs design is an experimental design in which the experimental units are paired up. The pairs are matched up so that they are somehow related. That is, the same person before and after a treatment. Twins, husband and wife, same geographical location, and so on. There are only 2 levels of treatment in a matched pairs design. So just like we looked at the randomized design, let's look at an example of a matched pairs design experiment. In this one, xylitol has proven effective in preventing dental cavities when included in food or gum. So a total of 75 Peruvian children are given milk with and without the xylitol and are asked to evaluate the taste of each. The researchers measured the children's ratings of the 2 types of milk. So first we want to identify the response variable in the experiment, which would be the rating that the children give to the types of milk. B, we want to think of some of the factors in the study, which are controlled. which factor is manipulated. So the age and the gender of the children are some of the factors, and the milk with and without xylitol is the factor that was manipulated. And C, what are the treatments and how many treatments are there? The treatments are milk with xylitol and milk without it, so there are only 2. Because of that, we can answer what type of experimental design this is. It's a matched pairs design. So let's identify the experimental units. Those would be the 75 Peruvian children. So why would it be a good idea to randomly assign whether the child drinks the milk with xylitol first or second? Mainly because this removes any effect due to order in which milk is drunk. Do you think it would be a good idea to double blind this experiment? Yes, certainly. That way, neither the children know nor the researcher, and can then not accidentally influence the outcome. Objective 5, we want to explain the randomized block design. Grouping similar or homogeneous experimental units together and then randomizing those units within each group to a treatment is called blocking. Each group of individuals is called a block. Confounding occurs when the effect of 2 factors or explanatory variables on the response variable cannot be distinguished. So a randomized block design is used when the experimental units are divided into homogeneous or similar groups called blocks. Within each block, the experimental units are randomly assigned to treatments. So let's look at an example of this type of designed experiment. Here we're going to look again at our English department, who's looking at an online version of their English course. After some deliberation, the department thinks there may be a difference in the performance of the men and women in the traditional and online courses. To accommodate any potential differences, they randomly assign half of the 60 men to each of the 2 courses, and they do the same for the 70 women. So our 2 blocks would be the men and the women. This is a randomized block design. Gender forms the block. This way, gender will not play a role in the value of the response variable, which was the test score. We do not compare test results across gender. And here is a good visualization of how that experiment was run. The total group of students was broken into the 2 blocks, men and women. Half of each were given online versus traditional, and then took the test, and we compare the test scores.